you're doing is like defining you have to define your variables. You're not allowed to just like switch your variables and not say what they are. So we're going to let u be negative x cubed plus 2, and that means that if we take the derivative of that, we'd get negative 3x squared dx. Don't forget the dx. So we don't have that. We have x squared dx. So we're going to divide by negative 3, aka take negative 1/3 of both sides. And then now we can replace the x squared dx with negative 1/3 du. And we can replace all of this with a u to the 6th. Then you'll integrate by adding 1 to the exponent, multiply it by the reciprocal of that exponent, and add c. And then when you're done with that, just go back and plug back in your negative x cubed plus 2 for u. So if your u is x squared, your du is 2x dx. We don't have that, we have 4. So we want to multiply by 2 so that this is 4.
I did that part.
So we're replacing this with 2 du. So this isn't part of the exponent, it's part of what's down here.
Gotcha.
And then now we just have e to the u.
Gotcha. Okay. That makes sense.
And then when you integrate e to the u, you just get e to the u. And then you plug back in your whatever u was, so our u was x squared. So 2e to the x squared plus c.
If, just like for argument's sake,
Yeah.
right? But I'm like in the process of it.
Yeah, so you still pick your like larger exponent for your u. And then we have a 6, so we need to multiply this by 3, which changes this to 3 du over u. You could also just write 3 over u with the du to the side of it, if that's less confusing. And then this is going to be 3 times the natural log of u plus c, which is 3 times natural log of x squared plus 3 plus c. Now if you have a natural log in there, you make that your u always, because we don't have any other option. Like, we don't know how to integrate the natural log of x. We haven't learned that. So we need to like get rid of this. We need to substitute something in for it. So you always choose, if in your integral you have a natural log, you always choose that as your u. So if you rewrite this like this, your u is the natural log of x, which makes du 1 over x dx. And so we have that here. So this says that we can substitute a du in for all of that. And then I can substitute u in for my natural log x. So I'm going to have u, and then I have to the 6th power times du. So all of this gets replaced by the du. So there's no like numerator, denominator, it's all just like one thing. So we have 1/7 u to the 7th which is 1/7 times the natural log of x to the 7th power plus c.
I have to write like a little thing next to it that says 18/4.
What do you mean? Oh, yeah,
Like a little line thing.
you should.
That's called like an integral mark, right? What's the verbiage?
Huh. You know, an integration symbol, I suppose. Yeah, I don't know that he has his own like specific name, you know?
Who?
Mr. Swooshy thing. I don't know that it has like a name. It's just
I
like
didn't realize
the symbol for
signs.
integration.
Yeah.
Yeah, I don't know what technically you should like put this in parentheses again, like notationally, since it's a binomial it should be in parentheses, and it just so happens to replace directly. If it was like 4x plus 6, you could take half of it. So just because it's a binomial doesn't mean you can't take a constant out or multiply by a constant. So you can always like multiply or divide even if it's two terms. So that's going to change that to du, and it's going to change the bottom to just a plain old u. And then you plug your 1 and your 3, you want to plug those into the u equals. So you're trying to figure out what would u be if x was 1 and we get 4. And then what would u be if x was 3 and you get 18. Then you integrate and you get the natural log of u. And then you plug in 18, plug in 4. Natural log properties, or in general logarithm properties, say that you can divide 18 by 4. When you do natural log 18 minus natural log 4, you can combine that to the natural log of 18 over 4. So that's the natural log of 4.5, or like 9 over 2.
That's what I was asking. Like,
Okay, yeah, I wasn't sure. I thought that was maybe what you were asking.
I was asking just like what do you do with those numbers?
I mean, you could like round it, but if you don't have a calculator or something, that's what you do. You would combine, if it was plus, which it wouldn't be because it's an integral, but let's just say it was. If it's plus, you multiply these numbers together, minus you divide the numbers. And then you just simplify. Yeah, if you have a calculator, then you can round, but if you don't have a calculator, you just gotta leave it like that.
It's too hyped.
Too hyped.
It's okay.
Alright, so u is 1 minus x squared, du is negative 2x dx. So you have to divide by negative 2 or multiply by negative 1/2.
That's right. So far, so good.
So that's the integral of negative 1/2, and then I'm going to put u to the 1/5 power.
What if Miss Rap makes this?
You're going to plug 0 in for x. So when you plug 0 in for x, you get 1 minus 0, which is 1. And then when you plug in 1, you get 1 minus 1 squared, which is 0. So this was like the one exception I was telling you.
Yeah.
That, oh yeah, so
We
like
got it right.
in some situations, the number on top can be smaller. Only in this situation, like when you're doing u sub. Then we integrate. So we get u to the 6/5 multiplied by 5/6, and we get negative 5/12. Whoops. Oh, I almost did it there, though. Ho, ho, ho.
Ooh.
Almost did it there. And so that's going to be 0 minus negative 5/12, which is positive 5/12. So if you did it the other way, you just would have gotten negative 5/12, which would have represented like a negative area instead of a positive area.
Plus 2 minus 2.
Yeah, x plus 2, or x plus 5 plus 2, and then also subtract 2.
C.
I don't know, man. I was thinking.
So that's x plus 7 over x plus 7, and then minus 2 over x plus 7. Those are your two integrals. Now integrate. So this one's just going to be x. And then for the second integral, you're going to say that u is x plus 7 and du is dx. And we have a 2 dx. So we're going to do
Multiply by
1/2.
Oh, wait, what?
Oh no.
Yeah, multiply by 2, right?
Yeah, multiply by 2. Yeah, because we need a 2 and we have a 1.
That was a quick, like, cover up and
Dang it.
draw. That's
I'm so quick with my whiteout. Alright, so then that makes this x minus the integral of du over u. There's a 2 in there somewhere.
Oh, there's a 2 before. Yeah.
Put a 2 here, you could put a 2 next to your du, or you could put it up here. And so that's going to be x minus 2 times the natural log of u plus c. And then you need to make sure that you go back and put in your u. So it's going to be natural log of x plus 7 plus c. Then, so u is 2x plus 1, making du 2 dx No, your quiz is like later next week,
Lift bars, let's get
Thursday.
this bread.
Can you not? I'm recording. So we're gonna take half of that,
I want to link to that.
which makes this the
I
integral
want that link.
of something over u du. We still have an x up here. So we're going to take this and solve this for x so that we can substitute something in for x. So that's u over minus 1 equals 2x. Take half of that to get x. And now we can plug this in for x.
What house works best for you?
Yeah, I also forgot this one half, so that goes here. I'm going to let this one half join this one half. That makes this a fourth.
Chris told me that your notes about 1 has 7 in it.
Yeah.
I want to split this up into two fractions. U over u minus 1 over u,
I'm kind of going to be bumper towards your
which can be written as 1 minus 1 over u.
inequality. So should I just go
Here. This integrated is u minus the natural log u plus c, and then you substitute back in your u
You want a bendy or regular?
while distributing the 1/4.